Good evening, Honors Algebra. This is the lesson, the flipped lesson for Wednesday night. Guess actually I've got the date wrong. It's only November 9th. Silly me, Mr. Lawrence. Oh boy. All right. Third period, you're not used to me making so many mistakes. First period, yeah, you know my secret. All right. Today we are going to quickly review the different types of problems that we know how to do from Chapter 5. We are not done with Chapter 5. It is a long chapter. It is a very important chapter. I thought today would be very important to stop and catch our breath. So first of all, the first type of problem we're going to review. Okay, on this graph I have 4 lines. It looks a little bit busy, but you can tell that I color-coded them. Do me a favor, see if you can count the slope of the green line, the slope of the orange line, the slopes of the blue line, and the gray line. Go ahead and pause it, see if you can count the slopes. My answers will appear momentarily. Okay, there you can see my answers. My slope of the green line is 2/1. Please remember, it doesn't matter if I count from point B to point C, point A to point B, or from point A to point C. I will get some fraction that is simplifies to 2/1. For the orange line, my slope was -3/1, and again, it doesn't matter if I count from F to G, G to H, or from F to H, or in the other direction, H to G, H to F, any possible combination you want there. I will get -3/1. Remember, only one of the values, the rise or the run, is negative in that situation, not both. The blue line is horizontal. Horizontal lines do have slope. Remember, if I could roll a ball on it, it has slope, and I certainly could roll a ball across a table that is level. It has 0 slope, meaning there is no rise, but it runs. Okay, and finally, the gray line, there is no slope. Whenever I count my fraction, my rise and my run, I end up with a number over 0. 1/0, 3/0, 2/0, -2/0. I'm never allowed to have a 0 downstairs. So that's a quick review of counting slope. Next, here I am giving 4 different problems. In each problem, I am supposed to calculate the slope of the line that would pass through those 2 points. Remember, my formula is y⁻² minus y⁻1 over x⁻² minus x⁻1. And that is how I find my slope. You're going to see I'm going to start use lowercase m for slope more and more often. All right, I want you to go ahead and calculate the slopes as best you can. Pause the video. You'll see my answers appear momentarily. Notice I did a smart thing. If I wasn't sure about my x's and y's, I went ahead and labeled them above each. Okay, the answers will appear momentarily. Here I've done the actual setup for you. Okay, like I said, my answers will be appearing soon. Of course, you could have labeled your points in the opposite order, in which case your numerators and denominators would be switched, not with each other, but in the blue one, it would be 5 minus 8 instead of 8 minus 5. If you look down on the black, you'll notice something changed. I had a small mistake when I set up the numerator, the rise. I had -1 minus 1. It should be -1 minus -1. And of course, a minus and negative becomes plus a positive. That happens here. That also happens in the red one. 10 minus -6 becomes 10 plus 6. So you can check your answers. The green one, -1/3. The blue one ends up being no slope. Of course, you could have given the answer undefined. The red one ends up with -9/16. And the black one as 0. Of course, you could say 0/-1. I would accept that. But please know that that simplifies to 0. Okay, now on to the next review topic. Okay, now we're going to review how to graph in slope y-intercept form. Remember, my general form of slope y-intercept form looks like this. Y equals mx plus b. And the y must be alone. When the y is alone, the b is my y-intercept. And the m is my slope, my movement. I get y alone. I find the beginning point, or the y-intercept, I plot that point, and then from that point, not from the origin, from that point, I rise and run based on my slope. So, looking at the blue equation, you can go ahead and graph these on your own graph paper. If you don't have any graph paper, make a sketch graph like Nathan Sperber did. I was so proud of him for doing that. All right, and pause the video, check it out, and then I will come back and you can see my answers. Okay, notice on the blue one I haven't drawn my line yet, but my y-intercept, my b, was 0. Why? Because there's nothing added to the end of the equation. So b is 0. That means my y-intercept is at the origin. I plotted the point at the origin. It's right there. Then my slope was -2 over 3, so I went down 1, 2, over 1, 2, 3. Down 2, right 1, 2, 3. To get a couple extra points and make a pretty line, I changed the signs on the slope. I did 2 over -3. Same fraction. Up 2, back 1, 2, 3. Up 2, back 1, 2, 3. I'm ready to draw my line. I'll do that in a moment for you. Let's jump over the green one. The green one was not in slope y-intercept form because the y was not alone. So I said 5 is keeping the y from being alone. It's attached by multiplication. So I have to divide by 5, but I have to remember to divide all 3 terms by 5. On the right-hand side, I'm actually distributing by division. So my new equation becomes y equals 3/5 x minus 2. My b is right here. So I put b in at -2. The y-intercept is -2. My rise is 3. 1, 2, 3. My run is 5. 1, 2, 3, 4, 5. I hit the point. 1, 2, 3. Right. 1, 2, 3, 4, 5. If I go back to my y-intercept, I could go down 3 and left 1, 2, 3, 4, 5. Again, all I did was change both signs of the slope. M equals 3/5 is the same as m equaling -3 over -5. The second one is not as simple. I would never give that as an answer, but I can use it to my advantage. All right, the lines will appear momentarily. Okay, and there are my 2 lines. All right. By the way, before we move on, I want to see if you can tell me what kind of equations, what kind of lines these 2 equations would produce. Give a moment, see if you can tell what kind of lines. The graphs will appear momentarily. If I wasn't sure, I'd make a t-table. Okay, I'd make a t-table for the green one if I wasn't sure. I need an x value. I don't know, I'll pick a number, 1. What's y? Well, the equation says y equals 7. I need a different 1. 7 would be right about there, I think. 10, 9, 8, 7, yep. Okay, I need another x. Well, maybe I'll take 2. Y equals 7. Y must be 7. So 2, 7 would be right there. Maybe I'll pick a negative, -5. But the equation says y equals 7. So y is always 7. So 1, 2, 3, 4, 5. You can see that I'm going to get a horizontal line. In the interest of time, I didn't draw using a straight edge. Please never do that. Please use a straight edge. I will make sure my next line looks much better because that line looks terrible. All right. For the blue one, I'm told that x is 7. I need a y value. I don't know, 1. I'm told that x is 7. I need a different y value so I can get a different point. How about 0? All right. Then I'm told that x is 7. Maybe I need a -3. I don't know. Just picking some points. So if I graph 7, 1, let's see, 8, 7, 1 right there. 7, 0, and 7, -3 would be right there. I will get a vertical line. And there you go. So the next one we'll review graphing from standard form. And then you guys should be ready for the assessment we're going to have tomorrow. So give me a moment, I'll get set up for the standard form review. Okay, so now we're going to review standard form again. And, you know, some of the kids like to go, oh, I don't want to learn the standard form shortcuts. They think they're too hard. But honestly, they are simple. Remember that to be in standard form, you must have the AX term plus the BY term equal the C term. And the coefficient on X the A term must be positive. If you are in this form, you are in standard form. When you are, you know automatically that the slope can be found by dividing negative A by B. You know that the x-intercept can be found by doing C divided by A. The y-intercept can be found by dividing C by B. Why would you do this? Because in some situations it makes it more simple. Now, I've gone over the 10-minute mark. I think YouTube's going to allow me to go 15 minutes. I hope that they will. If they don't, I'll splice it and split. But hopefully we can do this in under 15 minutes. All right, I'm going to put up 3 problems. Your job is going to be, 1, write them in standard form. 2, find the slope, x-intercept, and y-intercept. Okay, so here come your 3 problems. Go ahead and pause, and then you can check your answers with me. Okay, there are your 3 problems. Negative 4x plus 3y equals 12. Number 2 is 2y equals 5x. And number 3 is 4y equals negative 2x plus 12. Go ahead and turn them into standard form. Once you have that, I will do the standard form. And then you can find your slope, x-intercept, and y-intercept. Pause, get into standard form, and then check with me before you go to find the slope, x-intercept, and y-intercept. Okay, the blue equations are the standard forms. Notice in number 1, the A was negative, so I multiplied through by a -1. Or you could say divided through by a -1. Oops, looks like I have a small mistake. I need a negative sign on my 12. There we go. Okay, number 2, it was simplest to just subtract 2y from each side. So I get 5x minus 2y equals 0. It doesn't equal nothing, it equals 0. 0 is a number. And then on number 3, I added 2x on each side, and I get 2x plus 4y equals 12. Go ahead and find the slope, x-intercept, and y-intercept for each problem now that you have the correct forms. Okay, so there are the slopes, x-intercepts, and y-intercepts for each problem. If you have any confusion, please, please, please ask me tomorrow in class. All right, we're going to end the video here, and I think I'm okay on my length. So this is Mr. Lawrence, or Don Corleone, signing off. You guys are too young for that joke. Never mind.